Finally, we are at the position where we can define the gauge transformations of the potentials. Now everything is at our hand. We have studied all the prerequisites that are required to understand the concept of gauge transformations. Okay. First, we have studied different kinds of transformations. For example, coordinate transformation, Galilean transformation, time translation, etc. Before studying this gauge transformation. Okay. And we have found a very significant point regarding these different transformations is that generally a transformation in physics is related with some kind of invariance principle. Then we have defined the electromagnetic potentials through these equations. B is equal to curl of A and E is equal to gradient of V minus del A del T. Then we have discussed a very crucial property of these electromagnetic potentials, that the potentials V and A in these expressions are not unique, okay, corresponding to this electromagnetic field. Any arbitrary values can satisfy or represent the same electromagnetic field. That means any arbitrary values of these potentials can satisfy or represent the same electromagnetic field. We have already told that this crucial property of electromagnetic potential is the key point towards the concept of gauge transformations. Okay. The concept of gauge transformation is entirely originates from this crucial property. Okay. So now this is the time for us to define the gauge transformations of the potentials. So let us now define what gauge transformation is. Let us first start with the potentials V and A corresponding to the electromagnetic field E and B. Okay. Now let us consider some new values of these potentials A prime and V prime. Okay, where A and V will be all potentials, and now we are considering these new potentials A prime and V prime. Okay. Now since these potentials in these equations or in these expressions are not unique, as we have learned it from the study of this crucial property, so it means that the same electromagnetic field E and B we can also express in terms of these new potentials. Okay. That means we can write down B is equal to curl of A prime and E is equal to gradient of V prime minus del A prime del T, similar to these original equations. Now suppose these new potentials A prime and V prime are connected to the old potentials A and V through these relations. A prime is equal to A plus alpha and V prime is equal to V plus A. Okay. That means we have changed the value of the vector potential A to A prime by an amount alpha, and we have changed the value of the scalar potential V to V prime by an amount A. Okay. In other words, we can say that we have transformed the potentials from some old values to the new values. That means we have transformed the potentials from A to A prime and V to V prime, and we call these transformations as gauge transformations. Okay. So, this is the definition of gauge transformation. That means by gauge transformations we mean that we have transformed the electromagnetic potentials from some old values to some new values. That means A to A prime and V to V prime. Now the most significant point regarding these gauge transformations is that under these gauge transformations the physical electromagnetic field is not changing, as it can be seen from this set of equations. Okay. Initially we have expressed the electromagnetic field in terms of the potentials V and A, and now we are expressing the same electromagnetic field in terms of the new potentials A prime and V prime. Okay. That means under these gauge transformations of these potentials, this physical electromagnetic field is not changing, and this is the most significant point regarding gauge transformations. Okay, from this discussion now we can define what gauge transformations are. We can define that gauge transformations are the transformations of the electromagnetic potentials under which the electromagnetic field do not change. Okay. That means gauge transformations are the transformations of electromagnetic potentials under which the physical electromagnetic field does not change. And further, since the physical electromagnetic field is not changing, we can also say that these fields E and B are invariant under these gauge transformations. That means we say that fields E and B or the electromagnetic field remains invariant under gauge transformations. Finally, let us consider this definition of gauge transformation, or consider this discussion whatever we have made about gauge transformations from the point of view of the significance of transformation that we have discussed earlier. That means from the point of view of the invariance principle, as we have seen that a transformation in physics in general is associated with some kind of invariance principle. So let us consider the gauge transformations from this point of view, and from this point of view it is now clear that these gauge transformations are also associated with some kind of invariance principle, and this invariance principle is nothing but the invariance of the electromagnetic field. As we have already seen that this physical electromagnetic field in these two sets of equations does not change under these gauge transformations. That means the electromagnetic field remains invariant under these gauge transformations. The electromagnetic field remains invariant under these gauge transformations.